So we discussed options and corporate finance applications. There are mainly two applications. The first is how could we think about how could we think about equity as a core option? And then second, how do we think about debt as an option portfolio? And by saying debt can be considered as an option portfolio, we mean two things. First, we can consider debt as a option portfolio of firm's asset plus a short position in call option based on the firm's asset. And second, we mean debt can be considered as an option portfolio of risk-free bond with a short position in the put option on the firm's asset. So basically, you can see that we actually have three corporate finance applications using option theory. And then the key to understand why could we view equity as a core option and why could we view debt as an option portfolio is we consider the payoff, right? The payoff from these option portfolio or the call option. And we find out, let's say in the case of equity as a call option, we find out this call option has the same payoff, right, as the equity holders payoff. So that's why we can say we can view equity as call option. Clearly, you have to spend some time to find out what is this call options payoff, right? Because that's the key to understand why we could consider equity as a call option. And then by the similar methodology, we considered two kinds of option portfolios, and we find out in the end the option portfolio of firm's asset and a short position in the call option on the firm's asset have the same payoff as the debt holders payoff. So we could say debt can be considered as a option portfolio. And similarly, in the case that we have an option portfolio of risk-free bond and a short position in the put option on the firm's asset, we again find out this option portfolio has the same payoff as the debt. So in the end, we could say, okay, debt can be considered as this option portfolio. Okay, so let's end this chapter with a quite interesting problem. So let's see what this problem is about. So as of December 2014, Buffett Corporation had no debt. Suppose the firm's managers considering recapitalizing the firm at the start of the new year by issuing zero coupon bond with the face value of $90 billion due in January of 2017 and using the proceeds to pay a special dividend. Suppose Buffett currently has $300 million shares outstanding trading at $405.85 per share. So this implies a market value of $1 to $1.8 billion. The 2-year risk-free rate is 4.5%. Using the option market data in this table, estimate the credit spread Buffett will have to pay on the debt. So first, let me explain the question here. It says estimate the credit spread. So what is this? A credit spread. Credit spread is essentially the difference on the interest rate of the debt minus the risk-free debt, minus the risk-free rate. So let's say if this firm borrows at a debt cost of capital, let's say we have a firm, right? Google, right? Let's say Google has issued some corporate bond. So, and let's say these corporate bonds have a interest rate of 6%. And now let's assume risk-free rate is 4%. Then in this case, credit spread is 6% minus 4%. So here you can see that if we want to find out what is the credit spread Buffett will have to pay on the debt, the first step is we have to find out the interest rate on this Buffett Corporation's debt, right? So the key here is just to find out the interest rate of the debt. And now let's think about this. So how can we find out the interest rate? Well, you can see that we actually have the face value of the debt, right? So we have learned that if we know the face value and if we know the interest rate, now we can find out its present value, right? So basically, if you discount the debt face value by its interest rate, then you will get the present value or the price of the debt. But you can see that here we have a problem. We actually don't know what is the present value of the debt, right? So if we know, let's say if we know the present value of the debt is 80, we can actually solve R, right? However, if you look at this problem, it does not directly give you the value of the debt. It only gives you the face value. So how can we find out the value of the debt? Okay, now let's think, how can we find out this? First, we know that before this recapitalization, the firm had a market value of $1 to $1.8 billion. Right? So this essentially means the total value of the firm is $1 to $1.8 billion. Okay. And after recapitalization, remember that recapitalization here means that the firm, right, issues some debt, and by issuing debt, it will increase its leverage ratio, right? So we know that the firm's total value can be decomposed into the value of debt and the value of equity, right? So you can see that we can use the value of the firm minus the value of the equity to find out the value of debt. Now the question is, how can we find out the value of equity? Well, we actually cannot easily find out the value of equity here because you can see that this number is the value of equity before the firm issues debt. And now we want to find out the firm's value of equity after it issues debt, right? So the trick here is we can consider the firm's equity as a call option. And then we can use option data from this table to find out the value of the firm's equity. Right? So that's the basic idea here. Now let's solve this problem. Okay, so let's say the first step is we want to find out the firm's value of equity after issuing debt. Right? And from the last class we learned if a firm has debt, its equity can be considered as a call option, right, on this firm. And the option's exercise price is the face value of the debt. And we do know the face value of the debt. So we basically can find out the exercise price, right? So we want to find out the key here is we consider, right? So the key here is we consider equity as a call option. Now, what is this option's expiration date? Well, we learned when you consider equity as a call option, the call option's expiration date is the maturity date of the debt. And you can see that the debt will be due in January of 21/7. So you can see that its expiration date would be January 2017. And what is the exercise price? Oh, this is easy, right? Because we know that exercise price should be the same as the face value of the debt. So it should be 90 billion, right? However, we have 300 shares, right? We have 300 million shares. So this implies a per share exercise price of 90 billion divided by 300 million. Right? So this gives us a exercise price of 300 per share. Okay. Now we can use the data from this table. So we look at this option, which has the same expiration date, which is January 17. And the option with the same exercise price, which is 300. So we should use this guy here. And now we can find out what is the option price. Well, we don't actually have the price of the option. We only have bid and ask. Remember what is bid? Bid price is the highest price buyers are willing to pay. Ask is the lowest price sellers are willing to sell. So if we don't have if we only have bid and ask, the convention in finance is we use the middle point of bid and ask as the transaction price. So here the price of call would be the middle point of bid and ask. Right? So what can we get here? Okay, I'll just look at the answer. So it's 158.90, right? So now we can, so basically this means for one call, right, its price is 158.90. And now we have a total of 300 million shares. So we can find out the market value of equity, right, is equal to 300 million times the price of call. So this gives us a market value of $47.7 billion. Okay, so this is the first step, and you can see that it is the key step here, because we have to use this trick. That is, we have to use the price of this call option to value the firm's equity. We can do this because we have learned the firm's equity can be considered as a call option. Right? Okay, great. Now let's look at the second step. So in the second step, we will try to find out the value of the debt. This is easy, right? So debt equals the total value of the firm minus the value of equity. The total value of the firm is 121.8 billion minus the value of equity. It should be 47.7. So this gives us a price of 74.1. 74.1. Okay, third, let's find out the interest rate. So we know that by the discounted cash flow formula, right? We know that if we discount the debt face value by its interest rate, we can find out its present value. And we know that its present value is 74.1 and its face value is 90. Right? Now, how many years do we have here? Well, you can see that the firm will issue the debt at the start of the new year, right? To be more specific, you can see the timeline here. The firm will issue the debt at the start of 2015. Right? So at this time, the firm will issue the debt. And then the debt will be due in January of 2017. So following the lecture note, let's assume it will be due at the end of January. It will be due here, right? So let's say this is 2016 and this is January of 2017. So you can see that there are a total of 25 months. So how many years are 25 months? Well, it's 25 divided by 12, right? And then now we could solve the annual rate, which is 9.8%. So now we can find out the credit spread, right? It's just the difference between 9.8 and 4.5 risk-free rate. So this gives us 5.3%. Let me check. Yes, 5.3%. I would say that for these steps, they are quite typical, right? You don't need any tricks. The only trick is the first step. So the difficulty here is it's not easy for you to directly calculate the firm's market value of equity after recapitalization. And to find out it, you have to use the trick we just learned, considering the firm's equity as a call option. And then you could use the call option data to price the value of its equity. Okay, now let's look at the so-called chapter quiz. These are obviously essentially review questions. First, does the holder of a option have to exercise it? Well, the holder of an option has the right? The seller of the option has the obligation. Basically, it means that holder of the option does not have to exercise it. However, if the holder of the option decides to exercise it, then the seller will have the obligation to fulfill the order. Okay, second, does the investor who writes a option have a obligation? Well, we just talked about this, right? So if you're the seller or you're taking a short position in the option contract, then you do have a obligation. Third, explain how equity can be viewed as a call option on the firm. As I said, the trick here is you will think about the payoff of this call option, right? So I won't talk too much on this. The reason is because you need 5 minutes to show you can actually view equity as a call option. Okay, so let's move to the next chapter, which is the option valuation chapter. Again, the purpose is still about using options to understand corporate finance applications. But unfortunately, we have to first learn about some option evaluation techniques. And I have to admit, these techniques are actually a little complicated. So you might need to spend some more time in understanding these models. Okay, so the first guy is called the binomial option pricing model. So we will basically talk about three kinds of option pricing models. This is the first one. Right? So binomial option pricing model is a technique for pricing options based on the assumption that at the end of the next period, the stock's return can only take two values. So graphically, it basically talks something like this. You have two dates, day 0 and day 1. And you have a share price, S for today. And for tomorrow, you have two prices, S1 and S2. Of course, these two prices are uncertain. So this is the basic construct of binomial option pricing model. Now, the key insight of this model is, first, the purpose of this model is about pricing. That is, you want to use this model to find out, to calculate the price of a option. So how do you do this? Well, the key insight is a option's payoff can be replicated by a portfolio of stock and bond. And then by the law of one price. If the portfolio of the stock and the bond has the same payoff as the option, then the cost of this portfolio will be the same as the cost of the option. So basically, the cost of this portfolio will tell us the price of this option. Okay, now let's see this example. So we have a European call option which expires tomorrow and has a strike price of 50. The stock price is 50 today, and it's either 60 or 40 tomorrow. The stock pays no dividend. One period risk-free rate is 6%. And now our question is, what is the call price today? Right? Let's see what kind of data do we have here. So we basically have first the call, and we know that the call has a exercise price of 50, and the stock's price today is 50, and tomorrow it's either 60 or 40. And we also have this risk-free rate, right? So here K refers to the exercise price. So we have these data, and we want to understand what is the price of this call option, right? As I mentioned, we want to use a portfolio to replicate this call option's payoff, right? And we also mentioned we will use a portfolio of bond and stock, right? So let's see how could we do the replication here. First, let's consider the payoff of the bond and the call and this stock, right? Well, according to the problem, we know that tomorrow on day 1, the stock can be worth 60 or 40. And then we know that the interest rate is 6%. So if today the bond has a price of 1, then tomorrow its price would be 1 times 1 plus 6%, which is 1.06. What about the call? Now you have to be able to understand or to memorize the formula for calculating the payoff of a call option, right? So let's see. So if the stock price is 60 and this call has the exercise price of 50, so this basically means stock price is larger than the exercise price. So the call holder will be able to, or will want to, exercise the call, because a call with a strike price of 50 means the call holder will be able to buy the stock at a price of 50, right? But the market price is 60. So obviously it's better to exercise the call and buy it at 50. This implies the call option holder will have a profit, which is 60 minus 50, right? So this gives us a value of 10. And now, if the stock price on day one drops to 40, in this case, the option holder will not want to exercise this call option. The reason is because by exercising this call option, remember, its exercise price is 50. This means the call option holder will be able to buy the share at the price of 50. However, the market price is 40. So obviously the call option buyer will not want to exercise the call. So this implies the payoff from this call option would be 0. Right? Okay, now let's see how could we do the replication here. So we know that, let's call this as replicating portfolio. It's called replicating portfolio for obvious reason, right? We want to replicate, we want to use the portfolio to replicate the call options payoffs. So let's say we have a replicating portfolio which has stock and bond. The key here is we want to understand how much money should we put into stock and how much money should we put into bond to construct this replicating portfolio. So let's say we want to buy Delta shares and we want to spend B dollars into this bond. So now our question is, how can we find out Delta and B, right? That is, how many shares should we buy and how much money should we invest into this bond? How do you find out these two numbers? Well, remember, our purpose is to replicate the portfolio's payoff according to the options payoff. So this implies that, so if it is on a good day, the options payoff is 10, right? And we want to replicate this 10 by using our replicating portfolio. Right? So this implies 60. Oops. So this implies 60 times delta plus 1.06 times B should be equal to 10. So look at what is happening here, right? You have Delta shares and you have invested B dollars into the bond. And then if it's a good day, the share price is 60 and the bond price will become 1.06. And if you want to replicate the options payoff, then you will want to make sure that the portfolio's value is the same as the payoff of this call option on a good day. If it's a bad day, well, this result should still hold, right? So you can see that now the option portfolio, the option and the replicating portfolio still should have the same value. And the value of the option is 0. And the value of the replicating portfolio is 40 delta plus 1.06 b. So we have two variables, delta and b, and we have two equations. And by simple mathematics, we know that we can solve delta and b, right? So how do you solve this? Okay, now let's call this as equation 1, and this one is equation 2. So to solve delta and b, what you can do is you will use equation 1 minus equation 2. So if you minus these two equations, what you can see is on the left hand side, these two 1.06b will just cancel out, right? So this basically gives you 20 delta equals 10. So this solves delta equals 0.5, right? And then we can plug, we can substitute, boy, this is, and then we can substitute delta equals 0.5 into, well, you can substitute this into any equation. So into equation 2. So this tells us 20 plus 1.06b equals 0. So this solves b equals minus 20 divided by 1.06. So this gives us a number of minus 18 point, well, that's a long number. Right? Okay. Again, what is the trick here? The trick is these two equations. You want to make sure the payoff of the option is the same as the replicating portfolio's value under both good day and bad day, right? And then you will solve these two equations, which will give you the answer on the delta and on the b here. So what you can see here is, in the end, it basically means that to replicate the portfolio, to replicate the options payoff, you will want to buy half, so buy 0.5 shares. And then you will have some negative investment in bond. So what does this mean? It means you have a short position in bond. A short position in bond essentially means you're borrowing money, right? So it means that to replicate the payoff of this call option, you borrow money and you spend this money to buy to buy 0.5 shares of the stock, right? Okay. We can also verify that if we buy 0.5 shares and we borrow this amount, then our replicating portfolio will have the same value as the payoff of the option. Right? So basically you can see that so if it's on a good day, it's 60 times 0.5 plus 1.06 times minus 18679. So this will give you a number of 0. And then obviously, right, 40 times 0.5 plus 1.06 times this minus number. So this gives you 0. Okay, now having found out the value for delta and b is basically the first step, because our ultimate goal is to find out what is the price of the call option, right? Now, we know that this replicating portfolio has the same payoff as the call option. Then by the law of one price, this implies the cost of the replicating portfolio should be the same as the cost of this call option. So if we can find out the cost of this replicating portfolio, then we can use the cost as the price of this call option, right? So basically the first step is to find out the replicating portfolio. And then the second step is to find out the cost of the replicating portfolio. Okay. Now we know that we have 0.5 shares, and on day 0, right? This 0.5 shares value is 0.5 times 50. And then we have this amount of investment minus $18.8679. So we will just minus this number. So this will give us a number of, what's the number here? Okay, 6.13. Okay, so that's how you can use this binomial model to price the call option. Okay, now we can talk about before talking about the formula, we can talk about this picture here. So you can see that this blue curve, right? This blue curve gives you the payoff for this call option. And then this red curve gives you the payoff for this replicating portfolio, right? The reason is because the payoff of the replicating portfolio equals the price. So we have 0.5 shares of stock, right? So it's 0.5 times the share price minus I forget what's the number here. Okay, minus 18.8697. So minus 1.06 times 18.8679. Right? So that's the payoff of your replicating portfolio. This is the shares you want to buy. Of course, this is the share price. And this is your position in the bond. So what you can see here is if you draw this equation, you can see that if you plot this share price on this horizontal axis and the payoff on the vertical axis, you can see that you will get a straight line with a slope of 0.5, right? So this slope here is 0.5. So now you can see the trick here. So basically, the payoff of the replicating portfolio will be the same as the call option for only two possible share price, 40 at 50, right? And that's exactly what we want, right? Because at 40 and 60, if replicating portfolio has the same value as the call option, then we know that the cost of this replicating portfolio will give us the price of the call. Okay, now let's generalize this binomial pricing model. We know that the value of the call is given by S times delta plus B, right? What is S? S is really the stock price, and delta is number of shares. B is the amount of money you will invest in bond. Right? Now we can give you a formula to find out delta and B. So how do you find out delta and B? Well, so let's say the current stock price is given by S. And then let's say there are two possible share prices tomorrow, S up and S down. And if the stock price is S up, then the payoff of the option is C up. And if stock price is S down, then the payoff of the option is C down. And we denote the risk-free rate by RF. Okay, how can you solve delta and B? Well, it works like this. Remember, we're having a replicating portfolio. So we want to make sure that the replicating portfolio's value is the same as the payoff of this call option whenever the share price is up or the share price is down. So if the share price is up, then the replicating portfolio's value is given by SU times delta plus 1 minus RFB and equals CU. And then SD, that is when the share price is down, so SD times delta plus 1 plus RFB equals CD. And now we have two equations. So we use equation 1 minus equation 2, right? So in this case, you can see that we will have SU delta minus SD delta equals CU minus CD. So this solves delta, which is CU minus CD divided by SU minus SD. And then we can just basically plug in the solution of delta into either equation, and we will be able to solve B. So for example, let me substitute delta into equation 1. And you can see that B equals CU minus SU delta divided by 1 plus RF. Right? So you can see that now we exactly get B and delta as shown in this lecture note. Okay. Now let's see this example here. So use the equations we just solved to price the option in the previous slides. Well, this should be easy, right? Because if we look at this previous example, we know that we have two possible stock prices, 40 and 60. Right? So basically, SU is 60, SD is 40. And then what is CU? Well, we know that the exercise price is 50. So if the stock price increases to 60, then the options payoff should be 60 minus 50, which is 10. And then if stock price drops to 40, then this call option will just expire. So CD is just 0. And we also know that our F is 6%. So now we can solve delta, which is 10 minus 0 divided by 60 minus 40. So we solve the correct number, right? 0.5. And B is given by 0 minus SD, which is 40, times 0.5, 1 plus 6%. So it's minus 20. Right? Minus 20 divided by 1 plus 6%. I'm pretty sure you will get the same number, which is 18.8679. Okay. Now let's talk about the second model, which is called the black shows option pricing model. This is a really important option pricing model. So it's good if you can understand this model, because if you wanted to go further to learn something like investment, then you will have to understand this model. Okay. So now our purpose is to use this option pricing model to price a call option. So we're restricting ourselves to only thinking about call option. And we further restrict ourselves to price a call option and a non-dividend paying stock. So here we assume the stock does not pay dividend. And then the call options price is given by this formula. So let me explain. So this S, right, is today's stock price, where the current stock price. What is K? Well, we learned K represents exercise price. So PVK is the present value of exercise price discounted using the risk-free rate. Oh, actually we have these meanings here. S is the current price of the stock, K is the exercise price, and present value of K is the present value of the exercise price K discounted with the risk-free rate. Now the difficult part is ND1 and ND2. And the difficulty here is not related to finance, it's related to statistics. And if you want to understand ND1 and ND2, you have to know the normal cumulative distribution function. So let me first explain what are ND1 and ND2. Then I will spend some time to explain the normal cumulative distribution function. So ND is a standard normal cumulative distribution function. So let's say let's assume D1 is 0, right? Now what is ND1 equals 0 mean here? Well, it basically means the probability that a normally distributed variable is less than 0. And if you learned about this, right, you will know that N0 equals 0.5. Now, what is D1? Well, D1 is defined by this somewhat complicated formula. Right? So, sigma here, you can see that we have two sigmas. So, sigma here refers to the annual volatility. And T here refers to the number of years left to expiration. And again, PVK refers to present value of the exercise price. And S here again refers to the current price of the stock. What is ln? So ln is just a function. So it's a logarithm function. Okay. Now, after defining D1, we can define D2. So D2 is simple. It is the difference between D1 and the annual volatility times the square root of the number of years. So you can see that to understand this formula, I would say there's only one difficulty here, right? Because it's very straightforward to calculate D1 and D2, even if they look somewhat complicated. So the real difficulty here is about ND1 and ND2. So before you start panicking, I will tell you that in the exam, I will not ask you to calculate ND1 and ND2. So if there's a problem which uses this formula, I will directly give you several values of ND1 and ND2. Then you will choose the right one, right? So let's say if the correct D1 is 0.73, then I will tell you, right, I'll tell you N.73 is 0.39, and I possibly will try to confuse you and give you some other numbers. N.39 is 0.12, something like this, right? Okay, let's talk about this guy. Standard normal cumulative distribution function. So to understand cumulative distribution function, you have to first understand the probability density function. Right? So you can see that if you have a normal distribution, then the probability density function will be a bell-shaped curve. Right? And we know that the probability, right? The probability is given the area below this curve, is given by the area below this curve. So what is the cumulative distribution function? Well, you can see that the cumulative distribution function is given by this, I would say it's S-shaped. Right? So you can see that if you read from the curve, you can actually get some answers, right? So let's say you want to find out the probability that a normally distributed variable is smaller than 0, right? Then you can see that P0 is 0.5. So let's say you want to find out the probability that a normally distributed variable is smaller than -1, right? So this should be around, I guess, 0.1, maybe 0.18. So here we're talking about the probabilities. And from statistics, we understand probabilities has to be between 0 and 1, right? It's always non-negative, but it cannot be above 1. Okay, again, if you have any difficulty in understanding the normal distribution, don't worry, because I will give you the answer. I'm not trying to penalize you by testing your statistic knowledge. Okay, so for this Black-Scholes formula, you can see that if we want to find out the price of the call option, we need several inputs, right? Let's see what kind of inputs do we need here. So our purpose here is to find out this guy, this C. So what kind of input do we have? Well, obviously we need stock price, we need exercise price, and we need the risk-free rate. And we also need sigma, which is the annualized volatility. And last, we need the number of years until the expiration, right? So basically you can see that you need 5 inputs. This also means if you're given 5 inputs, then you will be able to price a call option. Okay, now let's see this example here. So let's say JetBlue Airways does not pay dividend. And using the data in the next table, so this table here, compare the price on July 24, 2009 for the December 2009 American call option on JetBlue with a strike price of 6, to the price predicted by the Black-Scholes formula. Assume the volatility of JetBlue is 65% per year, and that the risk-free rate of interest is 1% per year. Okay, let's think about the 5 elements we need, the 5 inputs. Right? So we need stock price, and we need strike price or exercise price. And we need risk-free rate. We need the annualized volatility of the stock. And last, we need T, that is number of years until the option expires. So the strike price is given by 6, and then the strike price is given by 6. The stock price is given by, I guess we have to find out from the table, right? So if you look at the table, you can see that the last transaction price of this stock is 5.03. So it's, don't get confused by this plus 0.0. So don't get confused by this plus 0.11. This 0.11 basically tells you how much the stock price has changed, right? So the actual stock price is just given by 5.03. So it's 5.03. And what about RF, the risk-free rate? This is easy, 1%. And then the volatility of the JetBlue's stock is 65%. And last, number of years, right? So how many years? Let me see. Okay, you can see that the price is, or the initial date is July 24, 2009. And then the expiration date is December 2009. So let's see how many months is. So I'm bad at calculating months or years. Oh, we have number of days. So we have 148 days until expiration. So basically, if we use December 2009 minus July 24, 2009, we will find out 148 days. Clearly, in the exam or homework, you're not expected to find out number of days by yourself, because to do this, you basically possibly need to check online or use some app. So I will just directly tell you how many days left. So you can see that now we can use this Black-Scholes formula, right? Generally, when you're using this Black-Scholes formula, you will want to start with D1. Right? So what is the formula for D1? So it's the logarithm of S divided by PVK and sigma T plus something. I can't exactly remember this. So it's sigma squared T divided by 2. Again, it's about plugging numbers, right? I guess here you have to find out what is PVK here. So present value of K equals 6 divided by 1 plus 1%. However, we have only 148 days, and a year has 365 days. So we will use 148 divided by 365. Right? So this gives us 5.976. 5.976. So we can basically plug in numbers now, right? So it's logarithm of 5.03 divided by 5.976 and then 0.65. So here, number of years is again given by 148 divided by 365 plus 65% and then 148 divided by 365 divided by 2. So this will give us a number of this. So minus 0.0209. And next, you will want to find out D2, right? So D2 is D1 minus sigma squared T. So it's minus 0.209 minus 0.65 times this guy. So this gives you a number of minus 0.623. Okay. So now we could finally use the formula, right? We know that C, that is the price of the call, equals S times ND1 minus present value times ND2. S is basically 5.03 and ND1 we know D1. So ND1 is given by so it's given by 0.417. 0.417 minus 5.976 times, so ND2 is 0.267, right? 0.267, which gives us 0.5. Okay, you might wonder, hey, how can I exactly find out ND1, right? So now I can show you how can you use Excel to calculate ND1 and ND2. Again, this is completely optional, right? I will not test you using Excel to find out ND1 and ND2. So remember, N here basically refers to the cumulative distribution function of a standard normal distribution. So to use Excel, you will use a function which is called normal distribution. So normal dist, right? And let's say what's our purpose? We want to find out ND1, right? So let's say we want to find out this guy here. So D1 is minus 0.209. Okay, I have never used Excel on an iPad, and let's try if I could. So 220 to press this. Okay, so it's minus point. Oh, I forget the number. Minus 0.209. And mean refers to the mean of this normal distribution. If it's a standard normal, then you would know that its mean has to be 0. Standard deviation for a standard normal has to be 1. Cumulative means, do you want to find out cumulative distribution? Yes, we do want to find out cumulative distribution. So here you would use this logical value, which is true. I hope I am correct. I guess for Excel, you have to use all capital letters. Oh boy. Okay. So it's 0.417, right? You can see that it's exactly 0.417. Okay, now you know how to calculate these distributions, right? Using Excel. Okay, that's great. Okay, so now we find out, according to the Black-Scholes formula, the price of the call is actually, so what's the price here? 0.5. Okay, that seems like a nice number. Now the question asks, compare the price, right? Compare the price in this option quote with the price calculated by Black-Scholes model. So now we have the 0.5, which is the price of the call calculated by Black-Scholes model. Now, what is the market price? So if we look at this call here, it has a strike of 6. So it should be about, I guess this guy? Yes, it is this guy. And again, you can see that we don't have a transaction price. We only have a bid and ask. Now we will look for the middle point. So the middle point is, it's exactly 0.5. So here you could say that the market price is consistent with the price calculated by the Black-Scholes formula. Okay, let me see, how much time do I have here? Okay, I think I would just, okay, I'll just stop here so we could talk about this replicating portfolio using Black-Scholes formula in the next lecture.